Wasn't that enough? Made my ears ring. Whoa. Oh, you should have been here. You should have been here. Oh, the whole thing's hot. It didn't even use up all the charge. Yeah, let's see if I can blow it too this time. Blew it in two? No, I didn't. I can't blow it in two. I can get it pretty hot though. I can get it pretty hot though. I don't think so. That's not bad for electricity though. That's all. This part may be a little hard to see, but this is the damage that was done to the wire. The wire didn't actually blow in two, and I didn't completely expect it to, but it ended up blowing about halfway through the diameter at each point of contact, and the wire was very hot to the touch at the end of the experiment. So I'm pretty sure I did produce 20,000 amps, but for just a very short period of time, and even that got the wire pretty hot. So the capacitor bank, in my opinion, is successful, and the sparks at normal real-time speed weren't much to look at. They're pretty good sparks, but slow motion gave a pretty impressive display, and this is by no means the end of the capacitor experiments, but this is where I'll stop at this point, and I'll provide more tapes later, and that's it for this part. Last night I constructed this beast to go along with Capzilla. This is a high current fast action switch where I used an actual rat trap as the operating mechanism of the switch, with a movable contact wired to the load side contact with 4 number 10 gauge flexible wires. In this case, I think it's like Amp King car stereo cable. Then I use a 3/4 by 1/16 inch copper strap to form the output terminal. The input terminal, I'm using a nylon unbreakable switch plate as the insulating material, and another piece of strap that's screwed with a sheet metal screw here to hold it in place. And the contact bolts are going to be, of course, expendable, and they're 5/16 inch bolts, which of course will be slammed together with considerable force whenever the modified latching mechanism is activated. Reverse the latching mechanism because the plate here would not allow the bow to clear, so I reversed the latching mechanism and modified it a little bit. I'll go ahead and zoom back out and do a demonstration of the firing without current, so that'll be like dry firing a weapon. So here we go. We'll fire it. Very effective. Our bolts don't line up exactly, but they are pretty close. And in the next scene I'll move this apparatus along with the capacitor bank outdoors, and we'll go ahead and give it a test firing. What I'm going to do is use 4 gauge cables to wire it up to a piece of 12 gauge solid wire, maybe about 4 inches long or so, and see if we can blow the wire into. This time we'll have improved contact action instead of a sloppy, weak contact. I'll have this powerful switch slam the bolts together, and I'm sure the bolts will spark, but we may have minimized losses at the switching point. I may be able to blow a piece of 12 gauge wire into at this point, but if not, we can use a heavy duty paper clip and blow it into, and we can do some other magnetic experiments, since we'll be able to produce a high current pulse, probably do the actual calculated 20,000 amps or better. So that's what we'll do. Let's see if I can set the trap with one hand. May not be able to do this. It's really not a very safe thing to do. But as long as my hands are clear of the impact area, there's little danger. Let's see if I can do this. That's relatively easy to set. If I can set it with one hand without getting popped, then it's really pretty effective switch. It's simple, it's powerful spring action, and we'll be testing it soon. While we have it on display here, while I can shoot it, I think I'll just get maybe as close to a 360 view as we can. This is a pretty good view right here. course, you have a reversed bow. You see the 4 number 10 wires. They're finely stranded for good flexibility, and they offer little resistance to movement, so the wiring is really good. Springs, as you can see, they're pretty powerful, and the switch plate's been banged several times without breakage, so it looks like it'll be an effective switch. And then we'll give one more shot of the very back of it. And you see the 4-gauge wires coming to the output terminal. So we'll move all the apparatus outdoors and we'll experiment and see if we can blow a piece of 12-gauge wire in two. Yep, I can do it. Try to. It'll be ready to fire in about a minute. No, I had to wait for the bulb to go all the way out, and I'll give it about another minute.